All right, we're going to talk about parabolas. I know we've graphed parabolas before. What type of function gives you a parabola as its graph? It's when it's x squared, right? So a quadratic equation, right? A quadratic equation. All right. Now, today we're going to talk about parabolas again, but in a different light. How do you get a parabola? So, all right, so suppose you have a random point like this, okay? And suppose you have a line like this, okay? Now, suppose also that I wanted to pick a point that was the same distance away from this first dot and from that line. So a point that is the same distance away from that and that. So let's say I put it over there, right in the middle, okay? Now, let me pick another point. I'm going to pick a point that's like, 5 units away from the dot and the same number of units away from the line. So look at, like, for example, this one. Okay, the same distance to the point as it is to the line, right? And I'm going to put that right there. Now I'm going to do another one. That's the same distance away from the point as it is from that line. So like, for example, this one. Do you see what I'm doing? Okay. Am I building a house though? So let's see. Here I'm going to put another point. This point, it's that far away from the dot and the same distance away from the line. So yeah, I am eyeballing a little bit, but if I do all of the points that are the same distance away from that dot as they are from the line, guess what I make? A parabola.
Oh, that's really pretty.
I make a parabola.
Wait, that was actually so cool.
You see that?
Oh, what? That was like a circus.
So let me erase these. So let me erase these. Okay. So what I am doing, if I do a random, so let's say I measure, 10 units this way, put a point, 10 units, 10 units, right? So measure a point over there. So it's 10 units away from here and 10 units away from there, and put a point there. Measure a point that's like 10 units away from this dot and 10 units away from the line, put a point there. If I do all those points that are the same distance away from that dot as they are from that line, I end up mapping out a parabola. That's what a parabola is, okay? Now, that dot, it's not a dot, it's got a special name. It's called the focus. So every parabola has a focus, all right? And this line down here is called the directrix. So we already knew that you can draw a vertical line through the center of the parabola, through the vertex of the parabola, and that's called the axis of symmetry, okay? So now, if I'm on the axis of symmetry and I'm walking down, all right, I hit a couple of key points. First thing I hit is the focus. I continue, I hit the vertex, I continue, and I come up on the directrix, all right? So all of those are on that axis of symmetry. Now, here is another magical concept for you. So look at that distance, okay, between the focus and the vertex, right? That distance. Guess what? That's the same distance as from the vertex to the directrix. So another way to say that is, if I'm standing on the vertex, all right, and if I walked 2 units up to the focus, then from the vertex, it's 2 units down to the directrix, okay? All right, so if I move from the vertex, if I have to move 10 steps down to the directrix, then how do I go from here to the focus? The same 10 steps up, okay? So it's the same distance from the vertex if I go to the focus or the directrix, okay? So a little bit of symbols and terminology. Remember this formula. We've seen this before. This is the equation, not the formula. This is the equation for a parabola. Remember? We did this in chapter 5. So it's ax minus h squared plus k. That's how you get a parabola. So basically, one of the variables is squared and y is alone. So now, okay, from here, we can get, so in chapter 5, we called this vertex form, if you remember. So from here, this variable and that variable, h and k, is my vertex. So vertex is h and k. All right? Now, what does this variable a represent? Do you remember what a did? So what is the difference? Okay, so suppose I had y equals 3x squared, or if I had y equals half x squared. If this number, like the 3, if it's greater than 1, I have a narrow parabola. If it's less than 1, it's a wider parabola. All right? So that's going to come in handy here. But in addition to that, what if I had 3x squared and negative 3x squared? What does the sign make? Right. So if a is greater than 0, which way does it open? It opens up. And if it's less than 0, it opens down. Okay? Now, let's talk about axis of symmetry. So suppose I had my parabola like this. Okay? And the vertex is at 5 and 2. Okay? What's the equation for the axis of symmetry? This is the axis of symmetry. X equals 5. Awesome. Okay? So, the axis of symmetry is always x equals the first coordinate, which is h. So remember, whenever it's x equals, it's got to be the first number, okay, which is h here. Now, suppose, okay, so this is the focus at 5 and, this is the vertex at 5 and 2. The focus is always inside the parabola, on the axis of symmetry. So in this case, this is where my focus is going to be for this parabola, right? So now, if I'm standing on the vertex, that blue dot, the vertex, in what direction do I have to go to hit the focus? Up. I need to go up. That means, can somebody give me a possible coordinate for the focus? 5, 4 is a good one. So did the x coordinate change? The y coordinate changed. So how do I find the focus then? Whoops. Yes, it's h comma k plus some number. Okay? Guess what that number is? Almost. Almost. So you see that magical number a? What we often do is we take a, almost, so first we multiply that by 4. Why 4? Because that's what the mathematicians tell us. And then I take the reciprocal 1 over 4a. And that's going to be a magical number for us. So here, how much do I go up from k? Well, 1 over 4a. Yeah, it's always 1 over 4a, never 1 over 4b or never 1 over 2a. It's always 1 over 4a. So now, if I'm at the focus, if I'm at the vertex and I go up a certain number of units for the focus, then from the vertex, where would I go to hit the directrix? Down the same number. So, For the directrix, it's going to be y equals k minus 1 over 4a. Okay, so let's do a little recap here. The axis of symmetry is x equals something. This one, the directrix, has to be the opposite, y equals something, because they're perpendicular. If one is horizontal, the other one has to be vertical and vice versa. Okay? Whatever variable I change for the focus, if it's the k here, then it's that same variable that needs to change for the vertex, for the directrix. All right? Does that sound cool? No. Believe it or not, we can also get parabolas that are lying on their side, sideways parabolas, huh? Well, believe it. Like that one, okay? So, when we had the vertical parabola, what orientation was the axis of symmetry? Vertical, right? So, if it's a horizontal parabola, the axis of symmetry is horizontal. Okay? So it's not going to be x equals, it's going to be y equals the number. And the directrix would be vertical, right? Okay? And where would the focus be here? It's always inside the parabola on the axis of symmetry. So there's one place for it to be. Okay? So focus would be here. All right, now, look at the equation for a vertical versus a horizontal. What's different? Okay, in the vertical case, what variable is squared? Well, x or y? X is squared, and in the horizontal, y is squared. So always think of it as, remember in like chapter 5, it was always y equals x squared plus 2x whatever, and you got your, parabola. So when it's x squared, it's vertical. When it's y squared, it's horizontal. Okay, so when a is positive, it opens to the right. When a is negative, it opens to the left. Okay, so that way for the right and that way for the left. All right? Now, vertex is always h and k. All right? Now, axis of symmetry. If it's a horizontal parabola, it's a horizontal line. So does it cross the x or y axis? Y axis. So it's going to be y equals k, because y always goes with k. X goes with h, y goes with k. Now, if I'm at the vertex here, up here, which direction do I have to go to hit the focus? To the right, horizontally, right? To the right. That means if I go to the right, if I go horizontally, does the y value change? Does the y value change if I go this way? No. Does the x value change? Yes. So for the focus, the x value is going to change. So it's going to be h plus 1 over 4a, but the k value will stay the same. Now, for the directrix, we do the same thing. It's x equals h minus 1 over 4a. Okay, so let me pause for some questions. So we've seen these forms of these equations before, right? Like this is how, the bottom one is how we always see quadratic equations, and then the top one, that's how we put it in vertex form. So here we're going to call that standard form, the way it's written on top. Do you remember completing the square? Yeah. Yes? Yeah. A little? That's what we're going to have to do here, is completing the square. Except before we did everything on on two sides. Now we're going to do it on one side. So you know what? Let's just do one problem and let's just remind ourselves how to complete the square.
You can complete the square.
Well, okay. So suppose it was this, okay? What we used to do is we said, okay, 2x squared plus 14x plus 7 is equal to 0. Then we took the 7 to the other side. And here we said plus a number, remember?
Yeah.
But before we did that, we have to factor out a 2, right? Because you can't have a coefficient in front of the x squared. So let's factor out a 2. Now, though, it's -7 plus 2 times a number. Do you remember? Just say yes.
Yes.
Okay. Okay. So what number is going to go in that blank? 7 divided by 2 and then squared, which was 49 over 4. Okay? And then what did we do? So this was 2 times. Now we could factor this like this. So it was x plus the square root of that blue one, 7 over 2 squared, equals whatever that mess turns out to be. Which turns out to be what? -28 plus 98 over 4, so 70 over 4. Okay? That's how we always did it. Now, though, we're going to do it so that everything stays on the same side. So the way we're going to do it now is, you see how you have this on top? So you're going to keep everything on one side. Everything stays on the same side now, okay? So let's move on to our actual problem here. Okay? All right, so let's do this first one. So y equals, factor out the 2. So I get x squared minus 6x plus a number plus 6. But now I'm going to do minus 2 times a number. Okay? 2 times because I factored it 2. Okay? So what number is going to go in the blank? 6 divided by 2 squared, 9, 2 times x minus 3 squared minus 12. Guess what? I'm done. That's the equation. So now, can I find the vertex from here? What is it? And -12. Where did the what come from? I factored this. So the square root of the first one gives you x. The square root of the last one, the blue one, gives you 3. There is a minus, so you put a minus and squared. Okay? It's always going to factor that way. That's completing the square. So does this open up, down, right, or left? Up. And what else do we need? What's the axis of symmetry? x equals 3. X equals, right, the h coordinate there. Okay? All right, so now I'm going to give you a few minutes. You're going to do part B all on your own. And I'll pause this for 2 minutes and we'll get next one. All right, so the next one, we're done with B. Now C. So C is y equals, okay? We're going to factor out a half from here. So it's going to be x squared plus. Now let's think about factoring a little bit. So suppose I have 3x plus 6, and I'm going to factor out a 3. What am I really doing to the 3 and the 6? Dividing by 3, dividing by 3. So if I'm factoring out a half, then I'm doing 12 divided by a half, which is times 2, which is 24x. Okay? All right, so now it's going to be plus a number minus 8 minus half times a number.
What's the number?
Well, now we're going to find the number. So 24 divided by 2, which is 12, squared, which is 144. You have no idea how much I love doing these. So y is 1/2, okay? X plus 12 squared minus 8 minus half of 144 is what, 72? So it's minus 80. There we go. I do. Okay. So, no.
Like, I sure do. I would believe it. I feel like when you go home, you don't do any math. Oh. Like, I hate that. I feel like you watch Jeopardy and be like,
I love Jeopardy.
I've been telling y'all.
And I do really well on the math and science categories. I do. Huh? Was he? Oh my gosh, I'd like to meet your demo. I have now I'd like to meet him like in a new light. Yeah. Okay. So what's the vertex here? Negative 12 and negative 80. X and Y. So it opens where? Up, and the axis of symmetry is x equals negative 12. Yes. Not since I was little. Okay. One more. One more. So, Zach, x equals 3 times y squared plus 5 over 3 plus a number minus 9. Yes. Minus 9 minus 3 times a number. Okay? So, it's going to be. Yeah. Yeah. So, it's going to be 5 over 3 divided by 2, which is times a half, squared. So, it's 5 over 6 squared, 25 over 36. So, it's 25 over 36. All right? Now, x equals 3 times y plus how much squared? 5 over 6 squared minus, wait, I'll tell you how much that is. So it's negative 133 over 12. Okay, so negative 133 over 12. So what's the vertex? Yup. And where does it open? Opens to the right. And what's the axis of symmetry? Y equals negative 5 over 6. So always look inside the parenthesis for the axis of symmetry. Okay? Now, I will stop here. I will make the homework not due next episode, due Monday then, right? However, listen, if you want to get started on the homework, because it will take a long time, if you want to get started on the homework, please feel free to do that. So we'll continue from here next time.